Right now, in the United States alone, a new person is added to the organ transplant waiting list every 9 minutes. 17 people on that list will die today. Not this year, today. But in labs across the world, scientists are building a future where that list simply doesn't exist anymore. Not by finding more donors, by growing the organs themselves. Livers, kidneys, even hearts, printed layer by layer, like a 3D printer, except the ink is alive. This isn't science fiction, it's happening right now. And by the end of this video, you'll understand exactly how close we really are and why the answer isn't as simple as just print an organ. Let's set the stage first, because the scale of this problem is honestly hard to wrap your head around. Over 100,000 people are currently on the US transplant wait list alone. Globally, that number is far higher. And the maddening part, it's not that we don't know how to do transplants. We've been doing them successfully since the 1950s. The problem is supply. Organs don't grow on trees. They come from people. Usually people who have just died, or in rare cases, living donors giving up a kidney or part of their liver. And there simply aren't enough of them to match demand. So for decades, the dream in medicine has been, what if we didn't need a donor at all? What if we could just build the organ? That dream has a name. It's called bioprinting. Here's the simplest way to picture it. Take a regular 3D printer, the kind that builds a plastic phone case layer by layer. Now swap out the plastic for something called bioink. Bioink is a mix of living human cells suspended in a gel-like material that keeps them alive and lets them hold their shape. The printer builds up the organ structure layer by layer, following a digital blueprint often based on a scan of a real human organ. Over time, in the right lab conditions, those printed cells start doing what cells naturally do. They connect, communicate, and start behaving like actual tissue. Sounds almost too clean, right? Here's the twist that took scientists decades to solve. An organ isn't just a lump of the right cells in the right shape. It needs blood vessels, thousands of them. Without a working blood supply, the cells in the middle of a printed organ simply suffocate and die within hours. For a long time, this vascularization problem was the single biggest wall standing between bioprinting and real transplants. And that wall is finally starting to crack. Let's get into what's real, right now, not decades away. One clever fix scientists have landed on: print a sugar lattice first, a scaffold shaped exactly like a blood vessel network, then print living cells around it. Once the tissue sets, the sugar dissolves away, leaving behind hollow channels for blood to flow through. It's a strangely simple idea for one of the hardest problems in medicine. Then there's the liver. One US research effort, nicknamed the Live Project, isn't even trying to build a permanent replacement liver. Instead, the goal is a temporary bioprinted liver that can support a patient just long enough for their own damaged liver to heal itself. Because, unlike most organs, the liver can actually regrow. If this works, some patients might never need a transplant at all. Lungs are getting attention too. One company has printed a human lung scaffold containing thousands of kilometers of tiny capillaries and hundreds of millions of air sacs. And in animal testing, it's actually exchanged oxygen. That's a massive proof of concept for something that once sounded impossible. Kidneys are further along in one sense and further behind in another. Scientists have successfully bioprinted miniature kidney structures that can perform basic filtration, but they're not yet complex or durable enough for a real transplant. And there's a completely different approach worth mentioning. Instead of printing organs from scratch, some researchers are genetically modifying pig organs so the human immune system won't reject them. A few patients have already received experimental pig kidneys and hearts in closely monitored trials. It's not bioprinting, but it's part of the same mission, ending organ scarcity by any scientifically sound path available.
Here's where we have to be honest, because this is the part most viral headlines skip. Bioprinted skin and cartilage, already approved and in real medical use. That's been true for years. Bioprinted heart patches and liver tissue, in active human and animal trials right now. But a full, complex, transplant-ready organ, like a whole heart or kidney, most scientists in this field will tell you we're likely still looking at another 1 to 3 decades before that becomes routine, not experimental.
Why so long? Because a transplantable organ can't just look right on a scan. It has to survive being sewn into a living body, handle blood pressure, resist infection, and function perfectly for years without failing. Every one of those requirements has to be proven safe before any regulator lets it near a human patient. So no, you won't be able to order a custom kidney next year. But the trajectory is undeniable. 10 years ago, printing a working blood vessel network was science fiction. Today, it's a Tuesday in a bioengineering lab. Think about what actually changes if this succeeds. No more waiting years for a matching donor. No more families facing an impossible choice after losing someone. No more black markets for organs, which tragically exist today because desperation creates demand that legal systems can't meet. And there's a deeper shift too. Right now, transplant medicine is reactive. You wait for a crisis, then scramble for a solution. A future with on-demand organs flips that completely. Doctors could treat organ failure the way they treat a broken bone today, identify the damage, and repair it on a predictable timeline. That's not just a medical upgrade, that's a fundamentally different relationship between humans and the fragility of our own bodies. So here's the real takeaway. We're not living in the age of lab-grown organs yet. We're living in the decade where they stopped being impossible. The organ that saves your life one day might not come from someone else's tragedy. It might just come from a printer. If this blew your mind, hit like and subscribe, because next time we're going even deeper into the science shaping the next 50 years of human life. See you in the next one.